All right, hello everyone. Let me go ahead and get started by hitting the share screen button as usual. I will be sharing my screen and then also jumping around to all kinds of different applications and web pages and so on. Spending most of my time in the web browser because our software is cloud-based primarily. We have some ability to do some offline work in Open-PHA, but that is not the topic for today. The topic for today is Vertigo, which is our SIS Safety Lifecycle Management software. So what I did is I went to our commercial website, just www.kenexis.com, and then when you hover over software, you'll see our full suite of software applications, or at least those applications that we've announced. Keep your eyes open for some more announcements before the end of the year. But today we're talking about our SIS Lifecycle Management and SIL Verification software, Vertigo. And that's this page. You might be wondering, where did Vertigo come from? So actually, the first piece of SIL verification software that I wrote back in the year 2000, I called SIL Ver for SIL verification. Unfortunately, I was at Exeter at the time, and they have retained that copyright or that trade name registration. So when Kenexis came up with its SIL verification software, I said, well, you know, it's SIL verification, but because we're in the cloud, everything is mobile, everything can go everywhere. So SIL verification to go kind of turned into Vertigo. Well, it is what it is. So if you were wondering where the name came from, there it is. On our commercial website, you're going to see a lot of information about the software itself. You're going to have a link to a lot of help files, other information, requesting live demos, but also the key here is when I click trial request and pricing information, it's going to take you down to the bottom of the screen. And as most of you know, we are very proud of our pricing strategy. So we publish it proudly on our website that our pricing is $5,500 per year. It's cloud-based software, so you do lease it by the year. There's no perpetual license. But it is leased by the seat. So all the people in your organization can have an account in KISS, the Kenexis Integrated Safety Suite, but only the number of users that you have licenses for can use it simultaneously. I'll go into that a little bit more when we get into the software. Here also, if you want a free trial, free 30-day trial to the software, you can click on this link and get it done automatically. But if you have broader needs for a larger organization, or you want more time, I am pretty easy about granting trial licenses, so just send me an email and I will set you up. Now, from the web page, we can actually get into the software by clicking the Kenexis Integrated Safety Suite login link right here, or you could just go to the website at kiss.kenexis.com. So when you log into the platform, you're going to end up on a page that looks like this. And we at Kenexis use single sign-on. So I'm going to sign on with our single sign-on provider, which is Office 365. We can do Office 365. We can do Google. We can do Okta. We have a wide variety of single sign-on providers that we are able to work with. Once you log into the Kenexis Integrated Safety Suite, you're going to land in the project manager portion of the application. And I think, let's see here, do I need to bump this up a little bit? Let me make it a little bit bigger, just in case some people are watching on smaller screens. So when you log in, the kind of landing page on the left-hand side is going to be a list of facilities. On the right-hand side is going to be the studies associated with those facilities. So I'm going to go to General Oil and Gas Operating Company, which is a company, a fictitious company that we created to do software demonstrations and training classes. And you'll see that when you get into a facility, you can create folders to kind of organize by region, organized by plant, organized by technology type. It's completely up to you. There's infinite flexibility on how you set things up. But I am going to go into the Texas City gas plant, into the separations area of the Texas City gas plant, where I have my information. Now, before I delve into the software itself, let me talk a little bit about the enterprise functionality. So this software is true enterprise software. Big, many users in many time zones, many continents, many countries. That is what KISS is set up for. We are set up for secure global sharing of the workload that is technical safety. And you know that for large plants, there are a lot of studies that are done by a lot of people that all need to be integrated together. That is the promise of the Kenexis Integrated Safety Suite, to make all of those applications accessible 24/7 globally, but securely. Now, when you have an organization, you're going to have a company administrator. That company administrator is going to be able to set the things that you're looking at right now, which are going to be your settings related to security and privacy. You're going to be able to add users, remove users, assign those users to groups, so that when you're doing assignment of access to different projects, you could do it as a large group at a time instead of a single person. And here is where we're also going to show your licenses. So as an enterprise user, you could look at this page and you could look at all the software applications that are available and see how many licenses for each application that you have. So right now at Kenexis, we can arbitrarily assign ourselves as many licenses as we want, but then you'll also see that you can tell the number of licenses that are currently in use. And right now we have 2 people that are using Vertigo. So Dave Lendl and Sean Cunningham are currently using Vertigo. Now, if I only had 2 licenses and I tried to log in, well, those 2 licenses are already being used, so I get a message saying your 2 licenses are already being used by Dave and Sean. So you're going to have to wait until they're done. Or if you're an administrator, you could simply come up here, click this X, and you could boot them off the system, especially if they like left for lunch and forgot to log out, and you don't want to wait the 30 minutes for the system to automatically log them out. Another thing here that we are going to talk about today is this thing called API integrations. The Kenexis platform has the ability for many of our applications to have data pushed in or pulled out of the application using an API. So this is the functionality that allows you to communicate with SAP PM, which is what we're working with one of our customers on literally right now. Sean is on with a customer integrating their SAP PM into their Vertigo application, so we'll talk a little bit more about that. But there are a lot of different use cases for these API integrations that we're going to get into. Okay, so let's get back into the main thrust of the discussion, which is Vertigo. But I'm not going to start in Vertigo. So you'll see here, for the Texas City gas plant separations area, we have a lot of different study types because there are a lot of different technical safety activities that occur over the course of a project. You're going to start with your Open-PHA, which is your HAZOP LOPA, kind of the starting point for all things risk. But then we're going to move into SIS design basis. We're going to move into effigy for fire and gas mapping, bow tie diagrams for results presentation, fault trees, either to do SIL verification straight up or to supplement the SIL verification that you're doing in Vertigo when you have really complex scenarios to address. So The starting point in that SIS safety lifecycle, clauses 8 and 9 in the standard, are hazard and risk analysis and allocation of risk reduction to protection layers. And that is done by done in our Open-PHA tool for HAZOP LOPA, for PHA studies of all kinds. So there is an entire webinar that we recorded on Open-PHA that's available through our website, but let me just kind of summarize it and suffice it and go to the very end, and you'll see that once you're done with a HAZOP LOPA study, you're going to have a list of safeguards that are referred to in various HAZOP and LOPA studies. And you have usually assigned a PFD or a SIL target to those safety instrumented functions that gives their performance criteria. And the beauty of what we're doing in KISS that no other platform is capable of is we're keeping the studies separate from each other, which allows for flexibility in the engineering process, the use, the data migration, but it links things together. So you'll see here for PT 101D, closing shutdown valve 101, that is the tag number, that is UZC 101A. I have a link here, and that tells me that I'm linked to a Vertigo study to do that SIL verification in the design of the S. So if I click there, it'll show me where I'm linked, and I'm linked to 2 places because I do way too many software demos. But when I click on this, it will then take me into the Vertigo study and show me directly where I'm linked. So let me back out of here and kind of get into the study the way you normally get into the study, which is simply clicking on the hyperlink to go into the study. When you go into the study, you are going to get a dashboard of a lot of real-time information about your safety instrumented system. So there's a summary of all the safety functions that you have, a summary of your SIL verification process, a summary of where you're at in dealing with recommendations that were generated in the study. Vertigo contains a mini light maintenance management system that a lot of operating companies use to actually track and document all of their testing of all their safety instrumented systems, and other companies will link the information of a more elaborate maintenance management system like SAP PM or Maximo. They will link that data back into our database so that we could do more statistical analysis on it using those APIs that I was talking about earlier. So right now we know that in the past 12 months we've had 2 failures. I can go view those failures. I can also set a checkbox to receive notifications on a monthly basis telling me how many items are past due for testing and so on. And then I can view all the tests. And then also there's this item over here related to recent events. This has to do with tracking of activation of the safety instrumented system that's required per the standard, and it's also highly recommended in that API 754 standard related to forward-looking statistics tracking on the operation of your plant. So all this is available on the dashboard. Now let me dive in to the IPF list. But before I do that, let me just kind of show you a little bit about how the software works. So in this action ribbon up on top, when you do an SIS project, you're generally going from left to right in how you do the project. So the furthest most to the left is going to be the IPF list. It's usually the first thing you do in your SIS project is...
Hey, they got a question out there.
Yes.
What is API?
API, okay, I said API twice and they mean completely different things. Okay, the API that I'm talking about when you move data from one database to another. So when I'm moving data out of SAP PM and bringing it into Vertigo, that is an application programming interface. So it's a series of subroutines that you could call over the internet that will take actions on your data structure. So for instance, our application programming interface has a call where you can create a new record in our maintenance database and push data into that record. So that API is application programming interface. I also mentioned API 754, which in that case, I'm talking about the American Petroleum Institute. And they're the standards body that writes recommended practices and writes standards related to all aspects of designing oil refineries and petrochemical plants. And the API 752 standard, or I'm sorry, 754 standard is the standard that talks about safety statistics, what you should track, how you should track it, and how you should report it through your organization. The first step is you build your IPF list, and a lot of times you're going to be able to automatically generate a lot of this IPF list from Open-PHA. So in Open-PHA, we have the ability to mass export all of our safety functions and create a new study or append them to an existing study. So you could do this in bulk directly out of Open-PHA, and I showed you how to do that during the Open-PHA demo. But if you want to add additional information, if you want to create something new, I can click Add an IPF kind of one at a time, and I'm going to create an item here. I'm just going to call it New, and I'm going to hit Insert. So when I did that, you'll see I have a blank safety instrumented function. Now I go to SIL Verification Summary, and over here there's a column called Link to LOPA. And when I click this button, I go and I can look, anywhere in the KISS system as a whole. But in General Oil and Gas Operating Company, I've got a Texas City gas plant separations area. And I want to go into this LOPA. Then I select what safeguard I want to link, and let's just call it this PT101D. This is why I have so many of those links. And then I hit link to safeguard, and now it's linked, but nothing shows up. So the link is there, and now I can go to synchronize and say, okay, this is the information in the Open-PHA study, this is the information in the Vertigo study, and I could copy stuff over. So sync the description, sync the tag number, sync the SIL target, sync the PFD, and we're good to go. When I do that, now all that information that I just inserted I've built too many copies of it, so it's right here. So it's this row here. So all that information now is tightly linked or actually, it's this one over here. It's tightly linked with Open-PHA. So you can bulk transport stuff out of Open-PHA, you can link stuff one at a time, and also on a regular basis for existing functions, you can always go and compare what's in the Open-PHA study against what's in the Vertigo study and make changes as required. Okay, so that's the linkage, and now I've kind of started down the road where I have safety instrument functions. But before I do this, let me get rid of those functions that I just created because I don't want them cluttering up my study.
Okay, looks like we have a question out there, Ed.
Sure. Yeah, absolutely.
Go ahead, David.
So does the Open-PHA software come included with the Vertigo subscription, or is that separate? And if you don't have your LOPA information and your PHA information integrated into the system, how does that play out, or how does that play with this? Because my company uses a different PHA management software, like PHA Pro.
Yep, nope, absolutely understood. So if you don't have your data in Open-PHA, that's not a big deal. There are a couple things that can be done. If you want to go crazy, you can import out of PHA Pro into Open-PHA. We've got a process for doing that import. That's probably kind of heavy-handed and clunky. The other thing that that would be possible then would simply be you would just have to type that information in. It's not the end of the day to have to type the information in. It's a little bit cleaner if you're using everything in the application, but if you're not starting with Open-PHA, then it's just a matter of typing stuff in. We don't right now have an automatic mechanism to do that, but as soon as you mention that, I know that PHA Pro should be able to export a safeguard list as a CSV file. There's no reason that we shouldn't be able to import that. So let me keep that in mind and put that into the software development platform. Now, in terms of cost, all of our items are sold separately, but we do have bundled discounts. And one of the most common things is the Open-PHA Vertigo Arbor bundle, but it is a modest increase over the price of Vertigo by itself to get all three of them bundled together. Continuing on, so once we get the data in, now we can go and we can start drilling down into the details. So out of our PHA, we got the tag, we got the description, we've got our SIL target, we've got our risk reduction factor target, and that's pretty much it. The next thing that we're going to need to do is we're going to need to build out our database. So now we're in the process of doing the conceptual design. And after we're done with the conceptual design, we're going to have all these results. So if you built a new safety function, you'd have a bunch of red lights and a bunch of error messages on those factors before you put information in. But we're going to put information in, and when you put information in, you do that down at the bottom. So you're going to see a tab for what sensors are included in the safety instrumented function, what logic solvers are included, what final elements are included. Do I have any recommendations to change the design? And I can also track my revisions to the design of this safety instrumented function. All that is shown here. Furthermore, on the right-hand side, you can see kind of the summary statistics of all the subsystems in terms of the PFD, spurious trip rate, fault tolerance, and so on. Now, what I'm showing you right now is I've got one group of sensors. That's a 2 out of 3 vote. I've got one group of logic solver, and I've got one group of final elements. So if you look up here, you'll see something called input group logic. The input group logic is one of the harder things to understand, but it is consistent with most of the software applications out there that do SIL verification, because to be honest, I wrote the first version of most of those software applications, and I applied this same concept. So there are at least 3 competitors that use similar technology because, well, I wrote the first version of their software. But I digress. So when you look at this input logic 1 out of 1, how would you change that? So let's say for sensors, instead of just a pressure measurement, let's say that there was also, I'm sorry, I didn't mean to do that. Let's say that there was also a temperature measurement. So temperature transmitter 104. So now my sensors that can activate my safety instrumented function are either a 1 out of 1 temperature or a 2 out of 3 pressure. that's when this input group logic comes into play. And you'll see I've got all these error messages because I've got two groups, but I said 1 out of 1 voting for the groups, which is not possible. So for the group voting, I have to choose either 1 out of X or X out of X. 1 out of X would mean if either the temperature goes high or the pressure goes high, shut down. X out of X, on the other hand, means I need for the temperature to go high and the pressure to go high before I activate my shutdown functionality. So let's make this 1 out of X, and you see when I made it 1 out of X, and I look over here, now I'm running these calculations again, everything's evaluating properly. Okay, but I don't want this temperature transmitter in here, so I'm going to uncheck it and return to where I was, and I'm going to go back to 1 out of 1 voting, and everything checks out. Okay, so that's the input group voting and the output group voting. The next thing that we're going to do is we're going to drill down into the details. So right now, you'll see that I already have a pressure transmitter in my system. PT101D, A, B, and C is kind of my voting arrangement for this sensor. And when I click on it, now I can drill down into the details about this particular sensor. So I've got a tag, I've got a service description, but before all that, I have the ability to select a type of device. So in my project library, I have all of these different types of devices available, and you'll see that I've got, I don't know, about 15, 20 devices here. Now, the important thing to remember is we have a project database and a general database. So all of these sensor types are included in my project. If I don't see a sensor in my project that I want to use, I can add a new type of sensor by clicking here. And when I do that, now it's going to bring me into the complete library of sensors from the Kenexis database. And this is going to include, I think we're up to around 3,000 or 4,000 sensors of various types. And those sensors are going to include generic, which is just kind of, displacer type level transmitter of any brand, or I have specific data of make and models from certification data from the equipment vendors. So I can select an item from the database. Now, I don't need to select an item from the database. I can also create black box models. So with, actually, let me not do that. I can type in custom information. So if I have a device that's not in the database, but I was able to get my own data from the field or data from the sensor, I would simply fill this in. What is the type, the description, failure rate, percent safe, safe coverage, dangerous coverage, and so on, architectural constraint types. So that's if you have failure rate data. We also have the ability to do something called a black box model. And honestly, the black box model is what probably 80% of your SIS logic solvers do not want you to calculate the PFD and spurious trip rate of their equipment in your software, or they don't want you doing it themselves. So if you go to a Siemens, if you go to a group Schneider with Triconics, they will tell you not to use packaged software to calculate the probability of failure and the spurious trip rate of their system, because their systems are very complex, and no canned software, no canned software, for instance, will model a Triconics correctly. Ask them yourself if you don't believe me. They have their own proprietary Markov models that the other software vendors don't have access to. So instead, they want you to go to them, and they will calculate the PFD and the spurious trip rate of the system that they sold you. So Triconix custom system, and then they will give you a PFD like 2E-6. They will give you a spurious trip rate like 1E-8. That's going to be in failures per hour. And then you do things like, well, you know, a Tricon's going to have a hardware fault tolerance of 1. It's going to be approved to SIL 3. Vendor report would be the item there, NA, and of course this is architectural constraint type B. And that's how you would put in most logic solvers. You would do this way. There are a couple of logic solvers where the equipment vendor has worked with Kenexis to allow us to model it directly. In any case, these are black box models, but black box models can get even more powerful in that if I have a very complex system, so let's say I have a pressure temperature compensated flow. Well, I can't give you a failure rate of a pressure temperature compensated flow. It's 3 devices with a complex relationship between the devices. In those types of cases, what we're going to want to do is we're going to want to model that tool externally using a tool with more horsepower, specifically fault tree analysis, and then we will link to the fault tree. Actually, let me not do that here because I already have these systems built up. I'll just show you the final result. So if I go here to my sensor types, you'll see that I have a custom configuration from a fault tree for a pressure temperature compensated flow. And when I built this type, I built it as a black box model. And so I selected the Arbor study that contains this information. And now when I go out of the Vertigo study, I can go into the Arbor study and you will see the fault tree. Results are out of date here, but because I keep monkeying with these things. Why do I keep monkeying with these things? Because I keep giving presentations, that's why. So here is a fault tree where we're calculating the result in terms of PFD, which is 2.04E-2 of this pressure temperature compensated flow, and that is then going to go directly into the Arbor study. I link to it, and when you see the results, there it is, 2.04E-2. So we're linking all of our studies together to give us one good clean interface for everything, but have everything linked together, so when I make a change to that fault tree, that changed PFD is going to show up on this page. Everything's linked together. So separate but linked is going to be the optimum in providing efficiency in our design process. Okay, so getting back to defining our sensors. So I'm defining a sensor, and as I mentioned, the starting point was a type. What is the generic type of sensor? Now that I've defined this pressure transmitter generic, it's something that I pulled into the project database out of the main database. Now it's available, and I can assign this to multiple different actual devices. So there's going to be a PT102, a PT103, a PT104 that are all going to be linked to this type of sensor. But for each instance of the sensor, I need to define what it is, how it's used. So I'm going to assign a test interval. I'm going to assign a voting arrangement, and you'll see that we have the full complement of standard voting arrangements. And this complex item is what's going to show up when you link to a black box model. Because when you link to that black box model, it's saying the architecture underneath here is very complicated. Go look at the black box model for more details. We give you a basis for how did you decide it is okay to use this device in a safety application. Most of the time it's going to be 61508 compliant or prior use. Proven in use is kind of an artifact of the 2003 version of the standard that we're probably going to get away from in the future. We have the status of the system, so you know that if you have an active plant, you might be designing a new safety function that's not in service yet, or maybe you might decommission a function, but you don't want to take it out of your documentation. So what is the status? I'm going to go ahead and call this one pending, which implies we're in the design process, but it's not being used yet. Reduced fault tolerance, again, is an artifact of the 2003 version of IEC 61511, which you should never use anymore. We have the ability to link to a PID so that you know what PID this device lands on. And we also give you the ability to link to a cause and effect diagram if you use external cause and effect diagrams. Okay. Now, we have our sensor, we've defined all the information about it, but that's not everything we need to know. If you've taken the ISA training class with me, you know that I talk about a channel or a leg. So a sensor channel is more than just the device itself. There's usually there's always the device, but there may be other pieces of equipment that can have dangerous undetected failure rates that we need to track. So we might want to put in a failure rate for a process connection. And again, you can pull items out of the project database. You can add items out of the Kenexis database for process connections. You might also have sensor interfaces. Like you might have trip amplifiers, you might have intrinsic safety barriers, or if one of the logic solvers that you're working with is Emerson's Delta V system, the charm that you connect your sensor to is going to be an interface device that is part of the channel of the safety instrumented function. So you build the channel from the sensor itself and potentially a process connection and a couple of sensor interfaces. Once that is done, the software does its work and you run your calculation. So the first thing you're going to do is you're going to sum up all of the failure rates for everything in the channel, and that includes your safe detected, safe undetected, dangerous undetected, dangerous never detected. And once the failure rates are calculated, then we do the calculations themselves. I've already done a webinar on the calculations that if you're interested more in the calculations, go to our website, look for the webinar where I talk about the terms. But for those of you that have taken the EC50 series, this item right here is going to be the DU term. This is the common cause term. This is the DD term, the online testing term, and then the imperfect testing term with all the parameters that impact those terms. So mean time or mean repair time is going to impact a lot of terms. Beta factor affects common cause. Manual proof test coverage and useful life are going to impact the never detected. And then you also have the check boxes as to whether or not you're going to consider those terms. So you'll see here in this situation, in this example, I'm not doing any online testing. If I wanted to change the design of my plant so that I am going to do online testing, I simply click the checkbox and put in the duration of that testing in hours, and it calculates the associated PFD and puts it into the system. So really, what you should be seeing here is that our process for doing this is hyper efficient in comparison with a lot of the other packages that you could use to do SIL verification. Now, at this point in time, we have built this sensor and it is complete. So you'll see that it's done, and you'll see that all the calculations have been done in terms of safe failure fraction, probability of failure on demand, spurious trip rate, fault tolerance. Everything is shown here. It's been calculated out. Now, if I want to use this sensor on another safety instrumented function, so let's just go to this low pressure separator. If I wanted to use that same sensor in this safety instrumented function, all I do is pick it out of the list and boom, there it is. So you don't need to redo things. Once you build a sensor type, you can use it in as many sensors as you want. Once you build a sensor application, you can use it in as many safety instrumented functions as you want, simply by linking. You don't need to build things over and over. And it's just a matter of when you get into the database and you do your drop-down list, it's going to show you a list of all the sensors that you've defined, and you simply pick which ones you want your calculation to be part of. All right, so that's kind of how you build up the sensors. You're going to build up the logic solvers exactly the same way, and you're going to build up the final element subsystems exactly the same way. If you come here and you go to the list and the sensor or the valve, the final element that you want isn't on this list, you simply go to this button, click Add New Final Element, and it's going to give you a blank worksheet, and you can build a new final element that way. Or you always have the ability up here in the action ribbon to hit this plus button and create a new instance of whatever it is that you're looking for. So there is where you achieve all of your targets. And at this point in time, we've run through our calculations and we've seen that we've achieved our SIL targets. Now, if we haven't achieved our SIL targets, we might want to put some recommendations in. So let's say, originally we had a 1 out of 1 vote, but in order to get to the SIL 2 target, we need to replace our 1 out of 1 vote with a 2 out of 3 vote. You simply put that in as a recommendation that goes into the overall recommendation tracking system that you're going to see on the project dashboard and also on the overall facility dashboard. So track recommendations, add new recommendations if you want to put a new recommendation in, and then we also have the ability to go to revisions. So once you've done your final design, you're happy with it, you have the ability to add a new revision. You could put in a description of the revision and the remarks. After you insert it, someone else is going, someone who is authorized is going to need to check and approve that. So we have all of that tracking information available in the software. So at this stage in the game, we've talked about the SIL verification process. And a lot of this stuff happened in the first tab, IPF List. So you see the list of safety functions. When you go to the SIL Verification Summary, it's going to give you kind of abbreviated information, but then also what were your targets, what did you achieve, did you achieve your fault tolerance, did you achieve your PFD, gives you the ability to link and check the information in your LOPA, and then it's going to give you a design green light. If you didn't meet your SIL target, it would be a red light, and so on. Another thing in the ongoing activity of the plant that we should talk about here are the events tabs and the revisions tab. So I already talked about looking at revisions on a function by function basis. So when you bring up the details for a function, you'll be able to see the recommendations for that function, or the revisions, not recommendations, revisions for that function. We also have a page where you can look at what are the revisions of all of the functions, and you can do mass tools. So if I want to make everything a new revision, I could basically take everything and make it Rev 1 simultaneously. So kind of some bulk activity action on the revisions page. Now going back to this events page, and I mentioned API 754. Also, if you go into clause 16 of the standard, when you're in the operation and maintenance phase, if you look at functional safety assessment stage 4, you know that you need to compare the actual operation of your equipment against the expected operation of your equipment. That's what this events tab is for. So if I go here and I look at UZC 101B, I can click here, and this is going to tell me, it's going to give me a list of all the activation events for this safety instrumented function. So what I could do is, so I see here this was activated twice, and it was given a tier 3 event severity in accordance with API 754. Tier 3 means that a protective function was activated, but there was no loss of containment in the plant. So basically every SIS activation is going to be a tier 3, whereas if you have an atmospheric relief valve, that would be a tier 2, because you did have a loss of containment, but it didn't result in consequences. So API 754 has a lot more information on that. So let's say I had an activation of the safety function. I can click here and add a new event. I could, put in the date and time. So it happened tomorrow at 7. I can check whether this is a valid event, and in the manual functionality, I can't click that it was automatically collected. I can just say whether it's valid or not. Why would you say something is not valid? Because the device activated, but it was because I was performing a test. So you have the ability to say, yes, that's valid, no, that's not valid. I could put in my 754 severity. If I use that, I could put in some notes about the event. Now, you remember I was talking about the other type of API, application programming interface. Now, this is where you might want to track this in Vertigo automatically. So what you could do is you could go to your plant's instance of Pi. Let's just say you're using OSI Pi as a historian. OSI Pi has application programming interfaces. Kenexis Vertigo has application programming interfaces. You just need some middleware like MuleSoft that on a regular basis is going to send a command to Pi to download the alarm log. Then in MuleSoft or some other middleware, you'll read the alarm log and compare the tags of the alarms against what tag would be generated if a safety instrumented function activated. And then if an alarm shows that a safety instrumented function activated, you would use the Kenexis API to then write that here as an event. So all that functionality is already available in the Kenexis Integrated Safety Suite to be doing this type of tracking automatically just by API calls between Vertigo and your whatever your data historian is. So those are the events. Okay, I kind of went a little bit forward in time. Dave, you have a question. Go ahead, shout it out.
Do you happen to know if you have any like API ties to Visium KMS? I know we use that for our incident tracking software. So we have categorized for incident, activations like, safety system activated or, other flags that we can put on incidents.
Right. So the answer is kind of. Here's the really sticky thing about these APIs. Everybody has APIs. Kenexis has them. SAP has them. OSI has them. The company that you just mentioned has them. But the APIs are only for their system. So your system is going to have the ability to push and pull data out of it. Our system has the ability to push and pull data out of it. All the magic, all the work, all the heavy lifting is in something called middleware. So what middleware does, and if you have some time later, research a company called MuleSoft. MuleSoft is probably the #1 middleware application, and it basically serves as the glue. So basically, the MuleSoft, when you configure it, you say, I want to talk to whatever the company was that you were just talking about, and I want to talk to Kenexis. This is the data from database A I want. These are the rules from what I want to push, and then when I push something, this is the database I want to push it into. So both of the systems need to have APIs, and then someone is going to need to configure the glue between these two systems. That's something that there are consultants that can do it. Kenexis can consult on it, absolutely. But what we're offering on our system is simply the ability to talk to our system, but someone is going to need to configure it at the end of the day.
I got you.
Yep. Okay, so we're a little bit out of sequence because all this stuff on event tracking happens at the end of the life cycle. We're talking clause 16, operation and maintenance. But we just barely did clause 11, or part of clause 11, where we are doing the SIL verification. So after I'm done with my project, I'm done with my SIL verification, you would think that you would be done with Vertigo, but you are not. Because the information about how to design the safety instrumented system needs to be communicated to someone else who is going to program your PLC, who's going to buy the components, who's going to lay out your cabinets, who's going to do your wiring in the cabinet and out in the field. So that mechanism of communicating information on the design of the SIS is the safety requirement specification, clause 10 of the standard. So as I go across my action ribbon along the top, I saw that I can create my IPF list. This button allows me to add new components, so new sensors, logic solvers, final elements, and so on. This button allows me to view things that I've created. And before we get into the SRS, we're going to want to hit this last SIS Tools button, where #1, we could do a validation. So basically what this does is it goes through every calculation and tries to find problems. And I have a problem in my sensors where it says for one of the sensors, PT002, I couldn't calculate the PFD because the vote to trip option is set to false and there's missing data from the MRT. So if anything doesn't calculate properly, when you click the validation, it's going to read through everything, and if it doesn't calculate, it'll tell you why it didn't calculate. You could copy this to a clipboard and send it to somebody to go fix it. All right, so at that stage, we're done with the SIS verification. We're ready to do our SRS. Kind of funny that we just finished clause 11, now we're going back to clause 10, but well, that's just the reality. Okay, so in safety requirement specifications, if you've taken an ISA training class with me, you know that I get up on the soapbox and preach about how most SRSs are absolutely horrible, in that they just kind of go on a function by function fill in the blank form that requires you to repeat information. It requires you to document things in places you shouldn't be documenting it. It's just a horrible, horrible way to do safety requirement specs. So the optimized, best-in-class approach for writing a safety requirement specification is the 3-piece process. Number 1, give me general requirements. Number 2, give me data sheets. Number 3, give me a logic description. And most of the time, cause and effect diagrams is the best way to do that. So for step number 1, we're going to set the general requirements. So general requirements are things that apply to absolutely everything in the entire safety instrumented system. So a good place for one of these general requirements is going to be something like action on loss of power, which is this general requirement here. So we say final control elements in general are going to move to their safe position when you remove power or any other means of motive force. This is de-energize to trip. De-energize to trip is the default configuration, and we're going to use it across the board. So we're using a general requirement so we don't have to repeat the same thing 100, 200, 300 times for every piece of equipment. Say it once and be done with it. That is the purpose of general requirements. So now you can, when you're building general requirements, you can click add a new general requirement and add them one at a time. Or you can import requirements from the library. So the Kenexis standard library has Kenexis's boilerplate list of general requirements for a safety instrumented system. Or you can have your own custom library for your company where you would set up what your general requirements are. When you hit the import requirements button, it's going to append them, not replace, append the requirements out of the library into the list that you already have. So that's how you build general requirements. The next thing you will do is build data sheets. So general requirements apply to everything in the SIS across the board. We have data sheets for IPFs, or safety instrumented functions, that apply to that function as a whole. So if I look at UZC 101A, I'm going to have information about SIL targets, modes of operation, HAZOP references, process safety times, and so on. Now, when you look at this stuff up here in the basic data, we already input that. So this information we already input during the SIL verification phase. This is a big relational database. We don't need to enter the information. And if we make a change here, so let's say this is pending, and I hit update, when I go back to my SIL verification, there it is, pending. That item shows up here in the SIL verification. And I don't know if you noticed this. You probably didn't notice this, but some of these fields rearranged since the last time I opened this form. That goes to show you that Kenexis is constantly working on developing, modifying, updating the software and making it better. So you saw that our software developers actually just pushed a change into this form while we're here on this webinar. So you don't need to wait a year for the next version of the software. When we make a change, it's literally available like the next time you load the form while you're actively working with the study. Anyway, my point was you'll see that that pending got changed over here on this form. So you never have to repeat data. Efficiency is the key. That's the key to KISS as a whole and Vertigo specifically. You're never re-entering data. You enter it one time and it gets used across the board everywhere where it's relevant. Okay, so in addition to the different data sheets for IPFs. We have data sheets for sensors, logic solvers, and final elements. Let me quickly pop up our data sheet for PT 101, which we've been looking at. You'll see that there is a lot of information on this sheet. And a lot of it, so tag, service description, voting arrangement, a lot of this stuff we entered in during SIL verification. It shows up here because it's relevant to the SRS, but we don't need to type it in again. Now, when you look at this form, you might say, man, Ed, there's a lot of stuff here that I am not really interested in seeing. So let's say, all this stuff related to the deviation alarm, I don't want to see that. Okay, here's the really exciting thing about Vertigo and about the Kenexis framework in general. We have one database with one data structure to make sure all your studies are consistent with each other and third parties know what the Kenexis database looks like. So don't be shocked if in the near future your equipment vendors, your logic solver vendors are going to be able to suck data in out of the Kenexis Vertigo database and automatically generate the great preponderance of your configuration of your SIS logic solver. So no promises on timing there, but I will say we're having some discussions. But we need to keep a consistent database, but different people want to see different things. How do we do with that? The superset. So if you're looking at basic data for a sensor data sheet, we have a superset of everything that anyone has ever asked us to track related to a sensor, but you don't need to look at it. So I can simply go over here to my settings, and I could go into this SIS tracked fields. When I go into my SIS tracked fields, I open up sensor, and then I could go to deviation alarm and say, I don't want to see any of this deviation alarm stuff. I don't do that. That's not relevant to me. I click update, and when I do that, now I go ahead and open that data sheet again, and all that stuff about the deviation alarm is now gone. So the ultimate in efficiency is a consistent, well-defined database, but flexibility in what I view. And those changes that I made to the view are not just on the data sheet you're looking at in the screen, they will also cascade into all the reports that you generate out of the software application. So that is our sensor data sheet. We have similar data sheets for logic solvers, similar data sheets for final elements, and as I described before, these data sheets are going to be customizable to show whatever it is that you want to see. And even if there's something that you want to document that you don't see on our data sheets, it's just a support email away to have us review and unless it's completely out of left field and crazy, we will probably add the fields in for you and make them available to you. Okay, and again, with the data sheets, we are applying information that is specific to that piece of equipment and not generic to the SIS as a whole, but efficiency. If this shutdown valve shows up in 12 safety instrumented functions, I don't need to repeat it 12 times once for every instrumented function. It's a relational database. You do it once and you're done. And when you make a change, it's going to cascade to every instance of that device wherever it's used. Okay, so in our SRS journey, we wrote out our general requirements. We filled out our data sheets. What's left? The complicated part, which is the logic. And let me reiterate, a lot of stuff cascaded. efficiency. So all this information that I highlighted, I input during SIL verification, but it became automatically available to me during the SRS phase. I don't need to type it in again. Well, the next step in the journey is our logic description. And in KISS, you can do logic descriptions a couple of different ways. You can do a plain text narrative description simply by adding in general requirements and just writing out the text. Most people, though, are more interested in cause and effect diagrams because the cause and effect diagrams are going to give you a really compact, tight, easy to understand description of the logic. So in terms of efficiency, well, I don't need to open up Excel, type in all my sensors, type in all my final elements. You have already typed this information in. What Vertigo does is it simply creates a grid. It knows all the sensors you put in, it knows all the final elements you put in, and it just draws a grid for you. And the information in the grid is populated in terms of the sensors and the final elements. And when you're working in this paradigm, you can actually click to bring up those data sheets and make changes if you want to, and the changes here will get cascaded into that design. And the only thing that you really need to do here is put the information in related to the intersections. And you could put in X's, you could put in short codes, or you can refer to notes that will show up in your general requirements page. So this tells me I've got an item 16 in my general requirements that's going to give me a more detailed description of what's going on in my logic. Now, when you're working in this cause and effect view, there are all kinds of tools. So you can lock the rows. Well, actually, I'm showing the whole screen. You can lock the columns so the columns don't move. You can show the main toolbar or not show the main toolbar, give yourself a little bit more real estate. And you can also break things up. So if you've got like a 600 IO point safety instrumented system, this cause and effect diagram is going to be ridiculously large. So what you can do is you can look at a subset. So I've defined IPF groups. So if I click this, USC 101, that is the collection of safety functions associated with the high pressure separator. When I make this change, now it's going to trim the cause and effect diagram to only show me the functions that are associated with the high pressure separator to make it a little bit easier to view and a little bit easier to work with. So I will argue, if you look at all of the SIS safety lifecycle tools out there, just this ability to work with cause and effect diagrams is head and shoulders the best. Because at Kenexis, we eat our own dog food and we do a lot of SIS design, and we know that working in this cause and effect view is going to be the most efficient way to get things done. Less repetition, quickest time in actually building things out. Okay, so at this point in time, you're done with your SRS. The next thing you're going to do is you're going to probably want to generate some documentation to go build the safety instrumented system. So we have the ability to do very detailed and sophisticated reporting. And our reporting is not going to send something to a plotter somewhere. We're generally creating documents that you're going to copy, paste, move, or maybe just print. So we have a lot of Microsoft Office integration. And even though I say Microsoft Office integration, one of our largest customers is a Google shop. So we generate something that is a Word document technically, but you can go ahead and open that up in Google, Google Pages, I think, Apple, whatever Apple, whatever word processor you're using, you can open it up. So we have a gigantic pile of different types of reports that you can generate. So something as simple as give me a list of all of the safety instrumented functions. You see here that I click that all button. This will print nothing. This will print all of them, and I can even kind of remove things out of the list that I don't want printed. I can hit generate report, and you'll see right here in downloads it created the IPF list. So I'm going to open that file, and then you'll see it created a Word document where I generated the IPF list. I can do summary reports. I can do detailed reports. So if I want the details of this safety instrumented function, now it's going to give me a multi-page report, 4-page report on this function. So so this is for the safety instrumented function. This is the overall results. These are the details for the sensor groups. These are the details for the logic solvers, the details for the final elements, and so on. What we just finished up with was our SRS. So you can generate a report for all the general requirements. Again, we're generating Word documents. That general requirements are going to look like that. Data sheets, either one at a time or print them all. And that's going to apply to sensors, logic solvers, final elements. And you can also print out the cause and effect diagrams, all of them, or again, one at a time, or any weird combination thereof. Little bit of a difference in the cause and effect diagram is that when you generate it, it's going to generate Excel sheets instead of Word documents. So you'll see that I selected USC 101 and USC 105. So that's what you're generating. Infinite flexibility in how you do your reporting, and it's going to generate one piece of vaporware, and I call it vaporware kind of tongue-in-cheek, is that I have a ticket right here, and you can see this yellow sticky note on my desk. It says, have Vertigo generate an entire report. So that's something that I'm going to put into the development pipeline, where instead of printing out all of these things one at a time and copying and pasting them into your Word document, you'll be able to select a template and generate the whole report all in one fell swoop. Those of you that are Open-PHA users know that we could do this for a HAZOP report. It's essentially going to be the same functionality. Okay, at this point in time, you're thinking, well, they got to be done now. I mean, we did the SRS, we did the SIL verification, we tied that backwards in the life cycle to our hazard and risk analysis. What more could they possibly do? Well, we can track testing. This is something that originally I'm like, oh my gosh, everybody has SAPPM or Maximo or something else. Why would they ever want to use our software to track testing? And the answer is because those other software applications are big, expensive, difficult to configure. A lot of people would rather take data out of SAP and bring it into our tool using an API because we can do a little bit more with it. So right here you'll see kind of the dashboard again on sensor, logic solver, and final elements. And guess what? Efficiency. All of this information, tag, service description, instrument type, test interval, was brought in from the SIL verification process. You don't need to repeat it. the testing section is automatically going to get a record for everything that you created during the SIL verification process. So once you have a device, you can put it into service by giving it a date commissioned. Once you give it a date commission, that starts the clock on testing. And then every time you perform a test, it adds that test record into the database. When you put in a decommission date, that tells the software this device doesn't exist anymore, and gray it out, essentially. I don't need to test it anymore, but you don't want to remove it from the database because there's valuable testing data that you're going to want to keep track of. So then you're also going to have a record of every test. So on May 22nd, 2017, I had a test and it passed. On January 22nd, 2019, I did a test. It failed, dangerous, undetected, and the mode of failure was that the taps were plugged. So you can track all of this information yourself. You've got the red light, green light, yellow light to tell you whether the test is 6 months or more in the future. Yellow means within the next 6 months. Red means you're past due. Gray means I don't need to test this for whatever reason. It's not installed, what have you, taken out of service. And then, yeah, so if you want to add a new test, you can do it like this. That seems a little bit tedious. If you want to use our software directly, what you'll usually do is you'll usually have a turnaround where you test everything, and if everything passed the test, you simply select everything, click add a new test, and in bulk you can say every one of these items passed their test, or you can, click on the items that didn't pass and you do your reporting by exception to say, what didn't pass and the information. So it's not the end of the world, honestly, to just do this tracking inside our software. But if you want to basically do your testing in SAP and bring it over into our software with an API, we have very large international chemical companies that are doing exactly that. So you'll see we have items for testing sensors, logic solvers, final elements to be able to track all of this information. Wow, these guys are really out of date. Let me go ahead and give them a new test. Just for entertainment purposes. Okay, they're all green lit now because I tested them today and they all passed. Now, before I leave testing, it's kind of a simple, light computerized maintenance management system. Obviously, we don't do like tracking spares and assigning people to it, and we're not going to. I shouldn't say that. People have talked me into stuff before. But the other value in keeping track of information here is that we can do statistical analysis. So I've done my testing. Now I can say, okay, well, what are my test records? So I could go here to final element types and say, tell me the failure rates on air-actuated ball valves generic, generate the report, and what it's going to do, and I've never done this one before, it might give me, yeah, it gave me garbage information. So I didn't have sufficient data. But let me go to sensors, and I'll do pressure transmitter generic high trip. So let me generate the report for that. And what it's going to tell me is that for that device, and let me make this legible to human eyes. It says, okay, so for this type of device, you've got 2 of them. They've been in operation for 165e to the 5th hours. Over that time duration, you have had 1 dangerous detected failures, 0 failures in the other modes, and based on that I can calculate a mean failure rate, and I can also calculate a 70% confidence limit failure rate. So this mechanism is giving you the ability to do that clause 16 of input the data for your testing, run a report, and say, okay, well, I assumed in my SIL verification calculations 5E minus 7, but my failure rate that I'm getting is 1E minus 5. I have a problem. I should probably go do something about that. Okay, so that's the kind of functionality that is kind of key to the SIS design basis, that your generic maintenance management systems aren't going to be calculating these types of statistics for you unless you have a very high-priced consultant do some custom programming. At this point in time, we have to be done, do we not? Not quite. One more little item that you might want to track in here. Now, there are a couple of places that people track their bypasses. We have the ability to do it in Vertigo. We also have the ability to do it, or we're going to have the ability to do it in our Intelligent MOC tool. So I probably shouldn't talk about Intelligent MOC because we have not done any announcements. Very few people know that we have an MOC tool in production. But I digress. So this is a place where you can manage your bypasses from an authorization perspective. And the beauty is you're linked to your equipment. So when you put something into bypass, you can manage it much more cleanly. So if I want to put something in the bypass, the first question that we'll ask is, well, what am I putting into bypass? So I want to put a sensor, or I want to put a final element into bypass. And then which one? So I want to put PT101D, A, B, and C into bypass. So the software knows what this equipment is. Then you'll put in the reason for doing the bypass. You'll put in the time that you want to put it into bypass. Let's just say maintenance. Then you put in some information about the types. So what do you, am I going to bypass a 1 out of 1 device? That has no fault tolerance, whereas a 2 out of 3 has fault tolerance. And am I going to complete the repair in under the MRT? Note to self, I need to replace these MTTRs with MRTs, or not? If the answer is yes, we're done. And I could put in an approval, I could put in some approval notes, hit insert the record, we're good to go. But if I don't have spare parts, and I'm going to be in bypass for more than 72 hours, I'm violating my SIL verification calcs, and I'm going to need to do what we call a bypass risk assessment. So you fill out this bypass risk assessment form for this scenario, make sure that the team thinks the bypass is tolerable in terms of risk, and then you do the approval. Now, let's say instead of a 2 out of 3, I was doing a 1 out of 1. So in 1 out of 1, I am not part of a fault tolerant system. So I'm going to need an alternate protection plan. If you think back to the IEC 61511 standard, you're going to have that compensating measures thing that you need to document and explain. So we are documenting when you bypass your SIS, you are documenting your compensating measures here. So what is the variable? What are the trigger points? Let me back out of here for a second. I'm going to cancel this, and let's say I want to do a bypass instead on LT101B. Where is that? I want to do it on this L. So this is obviously a 1 out of 2, which is going to be a type 3. Whoa! All of a sudden, all of my alternate protection plan got filled out. Well, these alternate protection plans are something that once you define it for a piece of equipment, it's probably not going to change. So you can either load them in ahead of time before you even start your plant up, Or if you create an alternate protection plan for a device, the software is going to remember it, and then the next time you want to put this device in bypass, it's automatically going to bring that alternate protection plan information into your database. So this is the Vertigo mechanism for tracking the authorization of bypasses. Now, what we don't have the ability to do yet is track the actual activation of the bypasses, but you know, give us some time. We have the APIs available. It's simply a matter of creating the data structure for the alarm activations, and that's going to allow us in Vertigo to actually do some auditing of bypasses, making sure that every activation is paired up with an authorization, and if we're seeing a lot of activations without authorization, probably time to do a little bit of discipline. All right, so now with that, now I am done. That is all that we're doing in the SIS Lifecycle tool. Obviously, the next step in the process will be your FAT, it will be your installation and commissioning, it will be your validation testing. I've talked on other webinars about using Open-PHA as a checklisting tool to help you in those other SIS lifecycle activities. But before I leave, you probably realize that there is a lot of features, there's a lot of functionality contained in this software, and I blew through all of it in about an hour and a half. So where do you go if you need more information? Well, we go back to the study list, and in the Kenexis Integrated Safety Suite, we have the training button. So the Kenexis Learning Management System, when I go into the Kenexis Learning Management System and I say browse available courses and I scroll down to the bottom, you will see all of the using training classes, and all the using training classes are always available for free, no charge. So when I click into using Vertigo, I will resume the course. You would have to click register if you're a new viewer. I hit resume course, it's going to bring me in. I'm going to stop that video, but you will see that there are videos that discuss every topic, every aspect of the software, whether it's working with grids, dashboarding, IPF details form, everything is in the training class. You're going to get detailed videos, explanations of how to do all of this stuff. And in addition, if you go under course documents, you'll be able to download the SIS Engineering Handbook, which just kind of gives you overview information on SIS design, the most recent version, and you will be able to download the Using Vertigo Workbook and Study Guide, which has information available. What should be in here that is not in here is the user manual. But if you want the user manual, again, now I'm back at the commercial website. If I go to the commercial website, you'll see the ability to contact technical support, contact Kenexis, or software help files. So when I click on software help files, it's going to bring me into the Kenexis support system. I click on Vertigo, and you'll be able to download the user manual. You'll be able to access the training, and then some additional materials. And then also you'll be able to see some of the more recent support posts related to Vertigo. And if you have a technical question, send an email, call, or simply fill out this form, and we will answer any question that you have regarding the software application. So that is the Kenexis Vertigo SIS Safety Lifecycle Management tool. From top to bottom, a fairly detailed presentation of the attributes of the software, but by no means is that comprehensive. More detail is available in that training class that you can access at no charge simply by going into the Kenexis Integrated Safety Suite application. So with that, let me turn the floor open.
Hey Ed, what about generating proof test procedures based on specific equipment?
Generating proof test procedures based on specific equipment. That is something that we have. I will say that in the Kenexis Research Institutes, in the software labs, we have some ability to do that, but it is by no means commercialized. It is not even in I wouldn't even say it's not even in alpha testing, but we have another application that it's complete, it's ready to go, but we don't talk about it because we kind of have our plate full. But we have another application called OpScope. But kind of making a long story short, there is an application where you can write procedures, and then once the procedure's written, you can put in videos to explain to people what you're supposed to be doing in the steps. You can put geolocation mapping of where you're supposed to be when you're executing the step, and all that runs on a smartphone app where you would, when you're executing the procedure, you do it off your phone and you'd be able to track it in the tool. So as I mentioned, we've kind of put that one on ice because nobody jumped on it. And again, we've got lots of things, lots of irons in the fire. But if that's something that you have a use case, a strong use case, where there's an end user that says, absolutely, I want this and I gotta have it, you know how to contact me.
We got a question here. It says, you reference using Open-PHA for other lifecycle data tracking. Would an end user use Open-PHA or Open Audit or a completely new feature, TBD, to document FSAs?
Okay, so a couple things. Right here in this separations area, I did another webinar where this General Oil and Gas Operating Company plant, I did commissioning. So the webinar is up. Just go to our website. You'll be able to view the webinar if you want to see it. But I built an Open-PHA checklist to do the commissioning for this plant. So I went in here, and if you go to checklist, so most of you that do commissioning, you use the folder method, which for every loop, you get a manila folder and you put in the P&ID, the loop diagram, the spec sheet, the SRS sheet, the cause and effect diagram, and then you go check out the loop. And when you're done with it, you put a green sticker on it if it passes, a red sticker on it if it doesn't, and then the project is commissioned when the red sticker box is empty and the green sticker box is full. Well, I kind of thought, well, we have electronic tools. Why are we using manila folders and boxes? Especially since these cloud-based tools, if you're doing a startup in Fort McMurray, but you're in Houston, it would be nice to be able to keep track of that without having to go to Fort McMurray, especially if it's the middle of winter. So I said, okay, well, how about if we do this virtually, where every instrument is its own checklist, and then one of those things that is in your folder is going to be a checklist. So is the You're checking to make sure that all the information is correct. Does the tag number agree with the P&ID? Does the model number agree with the data sheet? So you simply go through this checklist. If you answer yes to everything, it'll be 100% complete and you'll know, so you can always do tracking. So that's what I was talking about when going to the next step, and using Open-PHA as a tool to assist you in the commissioning process. But your question was specifically related to FSA. So I am gonna need to do a webinar on FSA. Chris, go ahead and throw functional safety assessment on the board as something that I need to do a webinar on. So I don't have an FSA complete for our facility here, but how would you do it? And I'm gonna go to something double secret, which is the 900 facility is where Kenexis keeps its templates. So if I go here into Kenexis templates, I have an SIS audit template. So for FSAs, an FSA is an audit. It's an audit that occurs for one specific stage in the SIS life cycle. So for stage 3, that means everything is done, my design, my commissioning, I'm getting ready to fire up the plant. So when I do that, I would go here into this template, and Open Audit looks very similar to what you'll see in Open-PHA. Note to self, I should probably put audit into an extended pro bundle to make it more available. But it's going to look very similar. So while you're doing your FSA, it's generally going to be team-based. I probably shouldn't have those people in there. I actually did an audit for a customer. So those were the people, these were the sessions, attendance, and so on. And then you have categories, and this is kind of broken down into phases. So you've got your stage 1, which is hazard and risk analysis. You're going to have your stage 2, which is your engineering and design. You're going to have your stage 3, which is commissioning, PSAT, and so on. This is your stage 4. This is your stage 5. And then this stage 6 is not done for FSAs, it's done for audits. And it's basically making sure that you've done all the planning, you have all your procedures and so on. So it's more of an audit thing. So if you were doing a stage 3 FSA, you would do these 3 checklists. So what's on the checklist? Well, let's drill down and look at the assessor worksheet. And I'll start with stage 1. So for stage 1 is hazard and risk analysis, it's LOPA, it's SRS. So that's a stage 1. And then we have a list of questions. And basically the question is the requirement rewritten. So this question is basically, I rewrote 615.11 clause 8.2.1. And then our tool actually has assessor guidance for what should you be looking for, what questions should you be asking. Here, you're going to put some notes with respect to what you found. So has a HAZOP been done? And then you could type in what you found. And then you could put in evidence. So that's one of the key differences here, is that we're going to have a relational database that says, I know the PHA was done because I have a copy of the PHA report that's in evidence of what I was doing. And then you're going to have kind of a list of all the evidence that you had, including documents and including interviews with team members. Then you put in your scoring criteria, so it's compliant, partially compliant, non-compliant. You can customize what you do here. You can even put scoring numbers on how compliant they are if you want to get totally crazy with it. So I'll just say, yes, it's compliant with the standard. If not, you would put a finding in, like my finding was that the PHA was never performed, or the PHA didn't identify all the safety instrument functions or whatever. And then you put in recommendations that would need to be closed out, and those recommendations are going to show up on a list, so you can it's a relational database, so the one recommendation can apply to many checklist items and so on. So this is the tool that I would recommend for doing FSAs, and this FSA template should be available to anyone who has a license to open audit. I need to double check that. But yeah, that's what we would recommend for performing and documenting functional safety assessment.
Well done, Ed.
Thank you.
Thanks again, everyone. Bye-bye.
Bye now.